Hey guys, Mr. T here, another video. This one's going to be on exponential functions. So we've been doing linear functions, drawing graphs of them, working out the equations. The next step is to do exponential functions, because that's what is the new thing at year 11. So an exponential function is any function where the variable is part of the exponent or an index, or you might know them as powers, like that. So for example, y is equal to 3 to the power of x. This is an exponential function because the variable x is the index or power of 3. X isn't like in a linear equation where it's not a power, it's just times by other numbers. Okay, so this example here is not an exponential function because the variable x is not part of any index or exponent or power. In fact, there's no exponent or power in that equation at all. So this is an exponential function because the variable x is part of the power. So in this course, what we're going to be doing is exponential functions with the form y is equal to a times by b to the power of x. So for an exponential function of y is equal to a times by b to the power of x, as the x power increases by 1, y is multiplied by whatever b is. And the value of y when x is equal to 0 is going to be a. So if x is 0, anything to the power of 0, so b could be 100, b could be 1, b could be anything. Any number to the power of 0 is actually 1. So if you times 1 by any number, you'll get the same number. So value of y when x is equal to 0 is always going to be a. So one way to think about it is when we talked about linear functions before, we said that variables with a linear relationship, in the two variables, when they're linear related, when one increases by a constant, let's say for 1, when x increases by a constant of 1, you add a constant to y. So the variables increase by a constant amount each time through addition. What's the difference here is with exponential functions is x and y are exponentially related. You can tell that when x increases by 1, then y is actually multiplied by a constant. So it's not adding a constant each time. You might be adding a constant to x, but y is being multiplied by a constant number instead of adding a constant to it, like with a linear relationship. So we're going to see some maths here to help with the understanding. So let's say we have the function y is equal to 2 times by 3 to the power of x. So some of your early questions are going to be asking, what's y going to be when x is equal to 0? So one way of writing that is y for 0. 2 times by 3 and substitute 0 there. Anything to the power of 0 is 1, so 2 times by 1 is 2. So for this function, y equals 2 times by 3 to the power of x. When x is equal to 0, y is equal to 2. What about the next one? When x is equal to 1, so y to the 1, 2 times by 3 to the power of 1. Any number to the power of 1 is itself. Basically all the numbers that we write are to the power of 1. We just don't write to the power of 1. So 3 to the power of 1 is 3. 2 times by 3 is 6. Okay. Now here we get to the tricky one. I've included this deliberately because you may not remember negative powers. If you don't, it might be a good idea to check out the start of chapter 13 of your textbooks. That's not on the timeline anymore. We're just expecting that you remember it because you've done it several times through the years. If you need to review, you'll have to ask your teacher. So it's going to be 2 times by 3 to the power of negative 2. Now, negative powers are the reciprocal of that power. So what that means is 3 to the negative 2 is actually the same as 1 divided by 3 squared. The negative power indicates that it's a reciprocal, so the opposite, the fraction like that, it's 1 over 3 instead of 3 over 1, which the whole number 3 is. And then the power 2 indicates that the number on the bottom is squared. Okay, so translating that to there, 2 times by 1 over 3 squared. 1 over 3 squared is 1/9, so that's going to be 2 over 9. Okay, 2 over 9. If I chuck that into the calculator, if you wanted a decimal equivalent for that, 2 divided by 9 is 0.222 equals 0.22 recurring. Okay. So that's it for the basic solvings there. Some of the other questions you might find are filling out a table of values below. So I like this, where you're filling out the table of values below. So it's like a multi-step process of just doing that. But the whole purpose of the table of values is to sort of help set you up for drawing a graph. Okay, so I could do this here. The function is y is equal to 5 times by 4 to the power of whatever x is. In this case, it's going to be x to the power of 2. 5 times by 4 to the power of 2 is 4 squared. 4 times by 4 is 16. 5 times by 16, 80. So 80 goes there. Y to the 1. 5 times by 4 to the power of 1 is 5 times by 4 is 20. Like we've already seen before. Anything to the power of 0 is 1. And so in this form, if when x is equal to 0, it's just going to be the a part of the function there, which is 5 in this case. So 5, here we go, for negative 1, y to the negative 1 is going to be 5 times by 4 to the negative 1. That means 5 times by a quarter means 5 quarters, or 1 1/4, and we know that to be 1.25. Then lastly, this y when x is negative 2 is going to be 5 times by 4 to the negative 2, which is the same as 5 times by 1 over 4 to the negative 2, to the 2, 5 times by 1, 4 squared is 16, it's going to be 5/16. If you wanted to work that out in the calculator, just do 5 divided by 16, that's going to be 0.3125. Alright, so that is examples, a couple of examples for the exercises. That would be 13b. Hopefully that helps you out, and I'll see you in the next video.